Quishing attacks are increasingly in the news as the adoption of QR codes by companies and providers grows. A lot of cases show how scammers and attackers deceive users by placing fake QR codes over legitimate ones. This deceptive practice leads unsuspecting users to phishing websites, where they become victims of scams and fraud. How is quishing typically executed? Commonly, companies use standard white QR codes on posters. These codes, usually seen as default and trustworthy, can easily deceive users. Their simplicity allows attackers to quickly tamper with multiple posters, making it difficult to discern which have been altered. Currently, most of the phishing countermeasures rely on user education. But as the industry and technology evolve, often their advancements are not aligned with the prevention of quishing. Standard QR formats are the norm of many posters and flyers, with safer features frequently hidden behind paywalls. Moreover, when a user scans a QR code, links often hidden behind dynamic or tiny URLs offer no clear indication of the destination, further aiding the deception. QR code providers market these dynamic codes as convenient for companies since they allow URL adjustments. Our solution, QR code integrity by design, incorporates simple but effective design elements and security measures to help users spot tampered QR codes. These features are intended to raise user suspicion, making it easier to visually identify a potential phishing attack. Additionally, this approach greatly increases the difficulty for attackers to lure people into their traps, as they now have to replicate each individual poster, requiring more time and effort. Research indicates that phishing occurs in 4 phases: visit, browse, consider legitimate, and intend to transact. An attack is only successful if a user is deceived through all these stages. Our project focuses on helping victims during the first and second phase, thereby reducing the number of users reaching the final phase and falling victim to quishing attacks. Further research shows that when users become suspicious during a phishing attack, they adopt a more systematic rather than heuristic approach. This increased caution helps them recognize the threat before it's too late. Raising suspicion towards the QR code and the website behind it leads users to be more careful when entering the website, potentially identifying the scam early enough. Our project demonstrates methods to defend users against quishing attacks, employing various attacker models ranging from basic scammers to sophisticated attackers. Depending on the attacker model, we propose different defense mechanisms to enhance the security of QR codes by design. In alignment with existing anti-quishing and anti-phishing strategies, we propose an additional layer of security, protecting users from these attacks